Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 11th, 2026, just yesterday. It introduces a sparse mixture of experts model that utilizes only 11 billion active parameters to match the performance of heavyweights like GPT 5.2 and Gemini 3.0 Pro. The paper is titled Step 3.5 Flash, Open Frontier Level Intelligence with 11B Active Parameters. And as we'll see later, the implications for efficient agent deployment are really significant. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, you can find Step Flash with 11 billion active and 196 billion total parameters. It includes quantized weights and examples for fast reasoning and agentic coding tasks. Figure 1 places Step 3.5 Flash head-to-head against leading models like Gemini 3.0 Pro and GPT 5.2 X High. The results span two categories, reasoning capabilities on the left and agentic capabilities on the right. In reasoning tasks like the IMO answer bench, the model hits 85.4% accuracy, effectively matching larger systems. Then, on the agentic side, it actually leads the pack on BrowseConf with 69%, showing that its efficient architecture still handles complex, real-world interactions. Okay, Figure 2 breaks down the architecture driving this efficiency. On the left, the mainstream uses a hybrid attention strategy. The model stacks layers in a 3-to-1 pattern, 3 sliding window attention blocks, which are fast and local, followed by 1 full attention block to capture global context. Then, on the right, we see the multi-token prediction modules. These extra heads let the model predict several future tokens at once, specifically the next step and the one following it, which significantly speeds up text generation. Well, while Figure 2 showed the design, Table 1 proves why it works. Here, the authors compare 4 attention layouts. The top row, FFFF, represents standard full attention, which is high quality but computationally heavy, costing nearly 3 times as much as the optimized versions in the relative flops column. The third row, S3F1, cuts that cost dramatically but sacrifices some accuracy. The winning formula in the bottom row is S3F1 plus head. By simply increasing the number of attention heads, the model regains top-tier performance, even outscoring the heavy baseline on pre-training, without giving up the speed gains. Alright, moving to the training dynamics, Figure 5 demonstrates the advantages of their new reinforcement learning framework, MISPO. On the far left, the reward plot compares it against the standard PPO algorithm. The blue line for MISPO rises faster and higher than the gray PPO line, proving superior efficiency. In the middle panel, the actor gradient norm reveals the cause. PPO exhibits massive spikes that indicate unstable updates, while MISPO remains smooth. Finally, the rightmost entropy plot shows that while PPO stops exploring almost immediately, MISPO maintains a healthy balance. So, Figure 5 showed the training stability. Now, Table 5 delivers the comprehensive benchmark results. It compares Step 3.5 Flash against heavyweights like Gemini 3.0 Pro and GPT 5.2. The first 2 data columns display the model's performance in vanilla mode and with Pocore, which is a parallel reasoning strategy. In the top reasoning section, for the math benchmark AME 2025, the score jumps from 97% to nearly 100% with Pocore, matching the best frontier models. Then, down in the general agent section, the BrowseConf results show it hitting 69%, beating both Gemini and Claude Opus. Alright, Table 6 lists the exact specifications that drive this performance. In the backbone and MoE sections, we see a 45-layer structure populated by 288 experts per block. Crucially, the routing row shows that only the top 8 experts are active per token, which keeps the computational cost low. Down in the attention section, the hybrid block structure confirms the 3-to-1 ratio of sliding window to full attention layers. Finally, the parameter counts at the bottom summarize the result. A massive 196 billion parameter capacity that runs with the speed of an 11 billion parameter model. Wrapping up, the big takeaway is that Step 3.5 Flash bridges the gap between frontier intelligence and practical efficiency. By utilizing just 11 billion active parameters, it offers a scalable foundation for deploying complex agents in industrial environments without sacrificing reasoning power. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.